Hello, my dear class 9 students, welcome back. So today we will continue with the part 3, that is chapter 12, sound, and this will be physics portion, okay. So in the last class we have discussed about how sound is propagated, and then we have also seen a relationship between the frequency, speed, and wavelength. We have done some numericals as well. Today we will discuss about reflection of sound. Students, in class 8, you have learned about reflection of light, right? That is bouncing of light. That's how reflection happens. That is how we're able to see our own image, or that is how we're able to see object around us. So same thing, sound also like reflection take place, okay? Now, reflection of sound means it is bouncing of sound wave. Clear? See, whatever I'm speaking, if it bounce, okay? Bouncing of sound wave traveling in a medium. Clear? Bouncing of sound waves traveling in a medium after striking the second medium. Then it is known as reflection of sound. Clear? So now one example, reflection of sound. The most common example is echo, okay? An echo. An echo is caused because of a reflection of sound. Okay, it is what? It is repetition of sound, right? Repetition of sound. Clear? An echo, I'm sure you have heard, right? So sometimes in an empty room, clear, or in a large hall, you can hear your own sound reflection, right? After the original sound, okay? See, now I'm speaking, right? Now after sometimes you'll get your own voice back. So that is an echo. So that is a repetition of sound caused due to reflection of sound. Clear? Now, students, but there is a condition. There is a condition. Now, see, I'm speaking something, but I cannot hear an echo, right? I cannot hear that sound reflection. Clear? Now, so there is a condition, okay? So the first condition is, suppose like this is the sound, okay? This is the sound. So maybe you are shouting, okay? Maybe you are shouting, and then this is the medium, okay? And this is the obstacle. Let's say this is the obstacle, okay? This is the medium. So you are shouting, and then this is the obstacle. So the minimum distance for an echo to hear, okay? The minimum distance for an echo to hear should be 17 meter. Clear? So keep this in mind, 17 meter. Suppose if it's just 10 meter also, you will not hear your own echo, okay? You will not hear that sound reflection. Why? Because the distance is lesser than 17 meter. So the minimum distance, okay? The minimum distance between the sound, okay? Between the sound and the obstacle should be 17 meter. So keep this in mind, okay? So that is the first condition. The minimum distance should be 17 meter. Now the second important point would be, students, see, suppose now I'm speaking, okay? Suppose now I'm speaking, so that will be an original sound, right? Original sound. Original sound. Now what happens? Original sound after reflection of sound, okay? After reflection, if it reaches our ear after 0.1 seconds, then we will get to hear the echo, okay? We will be able to hear an echo once the original sound after reflection, okay? After reflection, the original sound after reflection, if it reaches our ear after 0.1 seconds, then we will be able to hear the echo. Okay, now since I'm not able to hear my own echo, that means the sound is coming back, the sound is reaching my ear before 0.1 seconds. Okay, if the sound reaches our ear before 0.1 seconds, then we will not get to hear the reflection of sound. Okay, so it should be before or after. It should be after 0.1 second. Okay, so this is very important. Now see, from reflection of sound, the first point is, that is the bouncing of the sound wave, right? Bouncing of sound, that is a reflection of sound. And that example is an echo. An echo is a repetition of sound. Clear? Caused due to the reflection of sound. And there are two conditions that I've mentioned here for an echo to be heard is the minimum distance between the sound and the obstacle should be 17 meters. Okay? And the sound after reflection should reach our ear should reach after 0.1 second. Okay? Only after 0.1 second, if it reaches our ear, then only we'll be able to hear an echo. Okay? So that is all about reflection of sound. Okay? Now, okay, we are done with this echo. Now the next point would be reverberation. Okay? Okay, so my dear students, next point is reverberation. So this is also under a reflection of sound. Now reverberation is, say, in a large hall, okay, in a large hall, large halls, or in a big empty room, okay, you get to hear many reflection of sound, right? That is known as reverberation. So reverberation, in a simple word, okay, in a simple word, that is a multiple reflection of light, sound, okay, multiple reflection of sound. So that is reverberation. That is multiple reflection of sound. You get to hear many voices, okay, many voices of your own self, okay. So that is multiple reflection of sound, okay, and that is known as reverberation. And that you will experience that one in the large halls or a big empty room. Clear? So that is all. The next topic, students, the next topic would be the sound. Okay, I have already given you an example about the audible range. Okay, the audible range. The audible range for a human being, okay, to hear the sound would be between 20 hertz to 20,000 hertz. Right. So this I have already given an example, but students, sound, okay, sound below the frequency of this 20 hertz is known as infrasound, okay, infrasound. So infrasound means it is below 20 hertz, and for a human being, at least minimum frequency should be 20 hertz for us to hear, okay. Sometimes your friend whisper, okay, and you are able to hear, right? So at least the minimum frequency should be 20 hertz, and sound below the frequency of sound below the frequency 20 hertz is known as infrasound, okay, infrasound. Now we human beings, we are not able to hear below, or we are not able to communicate below 20 hertz, okay, but there are some animals who can communicate below 20 hertz. Clear? One such example would be rhinoceros. Clear? So rhinoceros is an example, okay, of animal where they communicate below 20 hertz. Clear? Now, students, see, below 20 hertz is infrasound, right? Now, sound above 20,000 hertz is known as ultrasound. Ultrasound. Clear? Infra below, ultra above. Infra below 20 hertz, ultra above 20,000 hertz. Clear? So keep this in mind. So that was about the audible range, and then infrasound and ultrasound, these are important, okay? So you can note it down. Now students, the next important term that we'll discuss would be sonar, okay, sonar. So what is sonar? So sonar stands, okay, the sonar, it is sound, okay, sound, navigation and ranging. Okay, so it stands for this one. Sonar, sound, navigation and ranging. Clear? Now, this sonar, it is a device, okay? Sonar, it is a device using ultrasonic waves. That means that has a frequency or above 20,000 hertz. Clear? Using ultrasonic waves to measure. It is used for measuring what? The distance, the direction, and speed of objects underwater. Clear? So it is a device. Clear? It is a device using ultrasonic. Okay, so now here when I mention ultrasonic, then it is above 20,000 hertz, okay, sound frequency. Using ultrasonic waves to measure distance, direction, and speed of objects under water. Clear? So note it down, student. Okay, so students, next topic would be timbre quality of a sound. Clear? Now this one, timbre quality of a sound. Now students, see, you have many friends, I know, right? And all your friends has different voice, right? And if your friend is calling you, okay, and from the other room, and so you are able to identify your friend, right, just by the recognition of his voice, okay? Just with the voice, you are able to recognize, you are able to identify your friends, right? You have 5 friends, all the 5 friends will not have the same voice, they will have a different voice, right? But you are able to identify their voice. Why? It's because of the timbre quality of a sound, okay? Timbre quality of a sound. It is because of this, you are able to identify your friend's voice, okay? Now, here one difference I want to, you can note down is between a tone and a note. Okay, tone and note. Now, what, okay, tone means that is a sound of a single frequency, okay? Sound produced because of single frequency. Single frequency, okay, that is a tone. And what is note? Now, sound that is produced because of a mixture of several frequency, okay? Several frequency. Mixture of several frequency, that is note, and then tone, it is a sound producing because of a single frequency. Clear? So, music is an example. Music is pleasant, right? Music is pleasant to hear, and that is an example for note. Clear? Okay, students will solve one numerical question, okay? we have already, in the last class, I have given you a relationship between the speed is wavelength into frequency, right? Frequency is represented by nu. We have solved numerical related with this relationship. Clear? So today, let's solve another numerical. Clear? Okay, so students, this is the question, okay? So let's solve this numerical together. So the question says, a person is listening to a tone of 500 hertz. So this is the frequency. Frequency is this one, right? Sitting at a distance of 450 meter from the source of the sound. Okay, so that is about the question, but what they are asking? They're asking, what is the time? Okay, what is the time interval between the successive compression from the source? So they are asking the time. Clear? So students, see, don't get confused. This one numerical that we have already solved was using this relation, right? But I have also given you the relationship between the time and the frequency, right? So time is this one, right? This is frequency. Clear? I have given you a relationship between this one. So now we have to find this one. So frequency is already given in the question. Clear? So now we know that this is frequency, okay, time is this one. And frequency, it is represented by this one, right? So given frequency is how much? It is 500 hertz. 500 hertz, right? So this one, what we'll do is we'll substitute here, that is 500, okay, 500. Now we'll divide this one. So if we divide this one, we'll get 0.02 seconds, okay, because the SI unit of time is seconds, right? So 1 by frequency, that is seconds. So the answer is this one, okay. So this one further, if you write this one, that is correct, okay. But further, what you can do is, this one you can write 2 into, you can write in this way as well, okay. So it is the same thing, clear. So this is all about the second numerical. So that is all for today. Thank you, students. We'll continue in the next class.